Okay, yesterday we went over the front and asked you to do these analysis questions. Now, when we do these analysis questions, we need to see if we can answer them using what we did. Which neighborhood filled up first? That should be an obvious answer based on the video that I gave you. Which neighborhood fills up last? That will be on the video I gave you yesterday. Was every house model available in every neighborhood? Was there an S, P, D, and F in every neighborhood? Well, if you go back and look, there's only an S here. They don't even have a P model, a D, or an F. So no, not all the models are available in every neighborhood. Okay, which neighborhood had the largest number of houses? Which neighborhood had the least number of houses? Did the electrons always fill one neighborhood completely before starting to fill the next? Not entirely. For the most part, it did, but there was one exception. And it's asked about on the next question. Why did the 4S house fill up before the 3D house? Okay, well, if you look at the 4S and the 3D, the 4S is 190,000. The 3D is 200,000. This is less energy than this. So it's going to go for the less energy one first and then move on to this one. So in this case, we're going to say it costs less. Now, atomic orbitals are probability maps showing where electrons are most likely to be found. Orbitals are designated by a number, 1, 2, 3, 4, called the principal quantum number, and a letter, S, P, D, F, called the angular momentum quantum number. The principal quantum number describes the energy level of an orbital and the distance of the orbital from the nucleus. The angular momentum quantum number describes the shape of the orbital. Y'all don't understand hardly any of that. I get it. But let's go ahead and look for the main information. What do the neighborhoods in this city represent? Well, if you go back, neighborhoods were 1, 2, 3, and 4. So go back to that paragraph. Do y'all see the 1, 2, 3, and 4? It's right here. And it says it's called the principal quantum number. So you're going to fill that in right here. Okay, principal quantum number. What do the different house models represent? Well, if you go over here, you have the S model, you have the P model, you have the D model, and then you have the F model. If you come back to this paragraph, you see SD, SPDF, and it's called the angular momentum quantum number. So you can fill that in right here. What do the individual houses represent? Well, it says down here which orbital shape the house model. So, orbital shape. If the cost of each house represents the energy in that orbital, which energy level or neighborhood has the least amount of energy? Well, of course, it's going to be the first level, and it's going to work its way up. So this would be, the least would be level 1. The most would be level 4. Which house model had the least amount of energy? So, for the least, that's going to be the one that has the lowest cost from the beginning. It's always going to be your S model. And which one has the most? Well, you're going to go down here, and the most is your F model. It costs the most. Okay. The electron configuration lists the orbitals filled by each electron in an atom in order of least energy to most. Superscripts are used to designate the number of electrons in each kind of orbital. An atom with 5 electrons would have the following configuration: 1s2, 2s2, 2p1. An atom with 15 electrons would have the configuration 1s2, 2s2, 2p6, 3s2, 3p3. And already you're probably like, what? I don't get it. Okay, well, we're going to do this a step at a time. Okay, so hang in there with me and pay attention. Okay, what would be the electron configuration for an atom with 2 electrons? So let's go back to our houses. and we have 2 electrons. Now, remember, in each house, we can fit 2 electrons. So this guy right here is by himself, so we can fill this one up with 2 electrons. So when you go to name it, it's going to be 1s and then 1, 2. 2 electrons. So you're going to write it down as 1s2. 1s2. What would be the electron configuration for an atom with 13 electrons? 13. Okay, so we're going to have a lot to go. So we have 1, 2. We're going to come over here and we're going to start at the next house. 3 and then 4, because each house can hold 2. So we got 4. Okay, now when we come to our P models, there are 3 locations that the electrons can be. We have to put someone in the house first before they can have a roommate. So you have to go 1, 2, 3. Y'all see how I did that? There's 3 there. So this is 2, 4, 5, 6, 7. Now we can go back and put a roommate. So this is 2, 4, 6, 8, 10. And we have to go to 13. So this is full. So now we go to our next level. Well, this guy, there's only one person, there's only one house, so there's 2 electrons here. So this was 2, 4, 6, 8, 10, 11, 12. And then we need 13. We're just going to put one guy right here. So now we have to label them. So we have 1s2. Okay, let's go look at our next house. We have 2s2. Okay. Then we've already labeled these 2, so now we're moving to the P houses. So we have 2p, and we have to count how many electrons we have in these houses. So 1, 2, 3, 4, 5, 6. I know that they're in different houses, but they're all grouped together in this model. So it'd be 2p, and then there's 6 electrons in all of those houses. So it's going to be 2p6. Okay, so 2p6, we're done with that. So now we're going to go over to neighborhood 3. Neighborhood 3, we have 3s, and then we have 2 electrons. So 3s2. And then we have 3p, and we only have 1 electron, so it's going to be 3p1. So all you're doing is counting, you're doing the neighborhood, the house, and then how many electrons. Okay, what would be the electron configuration for an atom with 28 electrons? It's a big one. Okay, so 28. Well, right here we have 13, so let's just keep adding. So we have 13. You have to add 1 before you can fill it up with the roommate. 13, 14, 15. Now add a roommate. 16, 17, 18. So that's 18. Now remember, we got to have 1 in each house before we can have a roommate. 2, 4, 6, 8, 10, 12, 14, 16, 18, 19, 20, 21, 22, 23, 24. Oh, I made a mistake. So, we can't do this one first. I do this every time. The reason why is because, look, we went from 180,000 to 200,000. We have to hit this guy first. We have to hit him first. So after the 3p, we have to go to the S model. So we had 2, 4, 6, 8, 10, 12, 14, 16, 18, 19, 20, and now we can go back to the D model. So 21, 22, 23, 24, 25, 26, 27, 28. Okay. So I messed this one up, but I want you to listen very carefully. So we're going to go ahead and we're going to do this right here, but we're going to stop here. So I'm just copying it over because it's still going to be the same thing. Okay. So now we're on 3 P's. So if we go over here and we find the 3 and you find your P's, you have 2, 4, 6 electrons. So 3p6. Okay, now the P's are done. We'd normally go to our D's, but remember I said I made a oopsie and made a mistake? Remember this one's cheaper, so I have to use this one first before I can go to the D model. So this would be 4s, and there's 2 electrons. So we have 4s2. And now we can go back and add our D model. So we have 3D, and it's 2, 4, 6, 7, 8. So 3D8. Now, neutral atoms have the same number of protons as electrons. The atomic number of an element lists the number of protons, so that's also going to give you the number of electrons. So what would be the electron configuration for carbon? So if you look at the periodic table, carbon is right here. It's number 6. So that means we have 6 electrons. So let's go back to our house. Okay. 1, 2, 3, 4, 5, and 6. Okay, so when I go to write these, I'm going to use my green dots this time. So I have 1s, 2 electrons. So 1s2. Okay, over here we have 2s2. And then we move to the p. So we have 2p, and we have 1, 2 green dots. So 2p2. Okay. What would be the electron configuration for magnesium? Magnesium, right here, it's 12. So we're going to have to do 12 electrons. Okay, so I'm going to do orange this time on my little houses, okay? So I got to do 12. So 1, 2, 3, 4. Remember, each of these has to have an occupant before we can double up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we go down here, 11, 12. So when we go to label it, you have 1s2. Here you have 2s2. Then you have 2p, and you have 1, 2, 3, 4, 5, 6, 2p6. And then we moved on to level 3, 3s, and we have 2 electrons. So 3s2. Sorry, my paper keeps sliding down. Now this can be very confusing. Use the houses to help you out. Okay, now for copper. Copper is right here. It's 29. Okay? Now, I'm going to come up here and show you. We already did 28, so I'm going to copy it until I get right here. Okay? So, we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, so we had magnesium. We had 28, and now we have one more, 29. So we had 3d8, and then we add one more electron, so we have 3d9. And that is going to be how you do electron configuration. I do get that this is very difficult for some people, and since you're at home, it's even harder to do, okay? But I do want you to work along with this and make sure you got it. Now, this right here will go into your notebook to help you.